In this section, we will be using our special triangles again, so make sure that you have those memorized. And here in this section, we will be talking about trigonometric functions of non-acute angles. So we want to look at angles that are larger than 90 degrees, and we want to be able to tell their trig function values. In order to do that, we have to first talk about what we call reference angles. A reference angle is the positive acute angle that is formed by the terminal side of our angle and the x-axis. It has to be the x-axis, so be careful that you're using the x-axis and not the y-axis. Here, let's look at this one first. Here our angle lives in quadrant 1, and we see that it is already acute. So the positive acute angle formed between the x-axis and the terminal side of the angle is itself 60 degrees. So the reference angle for 60 degrees is 60 degrees. So acute angles are technically their own reference angle. But if I get something that's non-acute, let's say 120 degrees, here we live in quadrant 2, we want to look at the angle that is formed, basically the distance between the terminal side and the nearest x-axis. So we actually want to know what this angle is. Well, if I was to go from here all the way to here, of course that would be 180 degrees. Well, I don't want all the way from here to here. I actually only want this red portion. So we actually want to get rid of everything from here to here. Well, if I get rid of that, that's actually 120 degrees. So if I subtract off the part that I don't want, we end up with 60 degrees. That is what we call our reference angle, the distance between the nearest x-axis and the terminal side of the angle. So that distance would turn out to be 60 degrees. So 60 degrees would be our reference angle. Okay. Now let's look at this one here. In this one, 210 degrees, we live in quadrant 3. And what we're looking for here is the positive distance between, once again, the x-axis, the nearest x-axis, and the terminal side of that angle. So I would like to know, what is this distance right here in red? Well, I want my distance to be positive. I want that angle, that reference angle, to be positive. So we always do larger minus smaller. Now, if we think about it, if I go all the way from here to here, once again, that's 180 degrees. If I keep going, of course, that would be 210. But what I would like to do is subtract off this portion that I don't want from the angle. So that would be 210 degrees. Take off that portion from 210 that I don't want, that 180 degrees, and we get 30 degrees. And 30 degrees would be my reference angle. And that is the distance from the x-axis to the terminal side. Let's say that my angle is in quadrant 4. Our terminal side lays in quadrant 4. Okay, once again, I would like to find the angle that is formed between the x-axis and the terminal side. So the nearest x-axis and the terminal side. What would that angle be? Well, when we look at our angle, we see that we are just shy of a complete rotation. If I go all the way around, a complete rotation, of course, will be 360 degrees. Well, I don't want a complete rotation. I actually want to get rid of all of this, because this is not part of my reference angle. Well, if I take off everything except for my reference angle here in red, that's actually subtracting off 315 degrees. So we get 45 degrees left over. So right here, this leftover portion in red is 45 degrees. And this would be called our reference angle. On the next page, we see that we have sort of a formula for finding the reference angle if our angle is between 0 and 360 degrees. So this only works here if our angle is already between 0 and 360 degrees. We want to graph our angle first, and once we graph our angle, then we're going to look for the distance between the x-axis and the terminal side. If our terminal side lays in quadrant 1, then if our angle is acute, remember we're talking about angles between 0 and 360, if we have an acute angle that lays already in quadrant 1, then the angle itself would be the reference angle. If we have an angle that lays in quadrant 2, then we want to find the distance here. So we want to take 180 degrees, which would be a half rotation, and subtract off the portion that we don't want. So we will actually want to do 180 degrees minus the original angle, and that will give us our reference angle. If we are in quadrant 3, then what we actually want to do is take our original angle, which will be larger, and subtract off 180 degrees. So basically we have our original angle, and we want to subtract off everything that made that half rotation, because we only want the portion that's left over after 180 degrees is gone. So we want to subtract off 180 degrees, and that'll leave us the portion that was left over after that half rotation. If we have an angle that lives in quadrant 4, then we will have an angle that lines up or is closest to the x-axis in quadrant 4. So that's 360 degrees. So if I was to have a complete rotation, of course, that would be 360 degrees. So we would say start with the larger value of 360 and subtract off everything you don't want, which turns out to be everything that was part of the original angle. And that'll leave us that little portion left over that was just shy of that complete rotation. So we'll do 360 minus the original angle. Remember that for these, we will always do larger minus smaller, so that our angle turns out to be positive, because our reference angle is always positive. And we are always working with the x-axis. We want to find out the distance between the angle, terminal side of the angle, and the nearest x-axis. So do not try to find the reference angle using the y-axis. Find the reference angle for the following angles. Our first angle is 294 degrees. The first thing we want to do is graph our angle. So 294 degrees, we're going to put that in standard position. Remember that this would be 0 degrees, this would be 90 degrees, this would be 180, 270. So our angle is larger than 270, so we will be over here in quadrant 4. So this is our original angle, 294 degrees. So we are living in quadrant 4, and we want to find the reference angle. I want to find this portion here in green. What is the distance between 294 degrees and the nearest x-axis? And remember that we want to think of it as the larger value, which would be 360 degrees, minus the smaller value, which would be our angle 294. And that will tell us the portion left over here in green. We put that into our calculator, and we get 66 degrees. So 66 degrees will be the reference angle for 294 degrees. Okay, what about 142 degrees? First thing we want to do to find our reference angle is to graph our angle. So this would be 142 would be in quadrant 2. And this time I'm looking for the positive distance between the terminal side and the x-axis, and I'm going to think about the nearest x-axis as being 180 degrees. So we want to do larger minus smaller. Since this was 142 degrees, it's smaller than 180 degrees. So we will do 180 degrees, take away 142, and that gives us 38 degrees. So our reference angle, that positive distance between the nearest x-axis and the terminal side, would be 38 degrees. So that is my reference angle. Okay, what about 207 degrees? We're going to graph this first. And that should put us just a little bit past a half rotation. And remember that we're looking for the distance, the positive distance right here between the terminal side and the nearest x-axis. Well, in this case, the nearest x-axis, we can think about that as being 180 degrees. But 207 is larger, so we want to do larger minus the smaller. And once we do that subtraction, we will find our reference angle to be 27 degrees. So this distance here, 27 degrees, and that would be our reference angle. Just one reference angle. Now, of all of these angles that we were given for A, B, and C, part D, we notice, is actually larger than 360 degrees. Part A, part B, and part C, all of them were in between 0 and 360. So for part D, when we graph this, we want to be careful to make sure that we know what quadrant that we are laying in. So as we go to graph this, we need to know how many complete rotations we have and then what's left over after that. So let's find a coterminal angle to this so that we can actually graph it. So let's take 360 degrees and divide it into our angle. When I do that, I get 3.14 approximately. So that means I have 3 complete rotations. So let's subtract off those 3 complete rotations. That means I'm subtracting 1080, and that gives me a coterminal angle of 50 degrees. So I'm going to go 3 complete rotations, so 1, 2, 3, and then this tells me that I need to go 50 degrees more into quadrant 1. So this one actually, I can just tell that the distance between the x-axis and the terminal side would be 50 degrees. So we don't really need to do a calculation here, since what the leftover portion was 50 degrees, and 50 degrees is already an acute angle. And I already know the distance between the x-axis and the terminal side because that was the leftover portion I went after doing my 3 complete rotations. So here we can say that our reference angle is 50 degrees. So that means that 1130 has a reference angle of 50 degrees. Now we can actually talk about how we use reference angles for non-acute angles to find their trig function values. Now remember that in section 2.1 we discussed how to find the trig function values for 30, 45, and 60 degrees. These are our acute angles, and we found those function values using our special triangles. We can do something similarly for angles like 240 degrees, something that is non-acute. First, let's start by graphing our angle 240 degrees. We're going to graph this in standard position. And we know that when we go to find our trig function values, we have x, we have y, we have r. We need to know the values for each of those. However, I don't know exactly what point to pick on the terminal side. So we can actually use reference angles and our special triangles to tell us which special point or which point to pick on the terminal side. So first of all, let's find the reference angle. The reference angle for 240, of course we want to know what this angle is here. Well, if this is 240 degrees, the nearest x-axis would be thought of as 180 degrees. So we want to do 240 degrees minus 180, and that gives us 60 degrees. So our reference angle is actually 60 degrees. So what we can actually do is arrange our special triangle to be right here, where 60 degrees is the angle of our triangle that is in that position. So that will be our 60-degree angle there. And we're going to arrange our special triangle to be right there, with 60 degrees being the reference angle. So this would be our 90-degree angle, and of course this would be 30 degrees. So we can arrange our 30, 60, 90 triangle to be in the same little place as our reference angle, and now we actually can tell which point we want to pick on our terminal side. So here's our terminal side there. And we want to know what is the x and y value of the point. And we're going to pick a point that actually ends right there at the very tip of our triangle. So what are our distances associated with our 30, 60, 90? Well, we know the hypotenuse is the longest, and that was 2. So that actually tells me that the r value that I will use will be 2. So let's go ahead and fill that out. So there's my r. And in the x direction, in the x distance, that's across from our 30-degree angle, so that would be 1. So we actually know that our x will be, well, let's think about that again, because if I'm going in the left direction here in the x direction, if I'm living in quadrant 3, then that x would actually be -1. And then my y direction, this side, is across from our 60-degree angle, which would be the square root of 3. So square root of 3, but I'm going down in the y direction, so that would be negative square root of 3. So we can actually use that special triangle lined up with our reference angle to tell us the distances in the x and y direction, and also the distance for r. So we use the point on the terminal side that lines up with our special triangle, and using those distances we can find x and y and r. Now how does that help us with sine? Well, we know that y is negative square root of 3 and r is 2. Cosine is x over r, so it's -1 divided by 2. Tangent y over x, so that would be negative square root of 3 divided by -1, and of course two negatives give us a positive. And then of course our reciprocals. If I flip this fraction, I will get negative, and let's go ahead and rationalize it. Okay, so if you flip it and rationalize, this is what we get. 240, if I flip that fraction, I get -2. And cotangent of 240, I'm going to flip this fraction and also rationalize. And we get a positive value on this side as well. Now let's look at our values that we actually get. You notice something about these values. All of these values, the numbers themselves, actually are all exactly the same as the trig function values of 60 degrees. So all of the actual numbers themselves are the exact same values as the values of our reference angle 60 degrees. So sine of 60 degrees was positive square root of 3 over 2. But we see the numbers themselves are the same for each of our trig functions. So cosecant of 60 is 2 square root of 3 divided by 3. Cosine of 60 is a positive 1/2. Secant of 60, positive 2. Tangent of 60, square root of 3. Cotangent of 60, square root of 3 divided by 3. So all of our trig function values have the same number as our reference angle, 60 degrees. What's the only difference between the values for 240 degrees and the values for 60 degrees is going to be the signs of each of our trig functions. We know that in quadrant 3, the only thing that is positive is tangent and cotangent. And when we go and look through all of our signs, we see that tangent is positive, cotangent is positive, and the other 4 trig functions are negative. So in order to find trig function values of non-acute angles, the first thing that we will do is find the reference angle. Once we have the reference angle, we actually know all the numeric values of all of our trig functions. Then we will use the quadrant to tell us what signs should go in front of those trig functions. Alright, here we're going to do another one, but we're going to kind of streamline the process a little bit. One of the things that we know is that the reference angle for 150 degrees will tell us all of the numeric values of all of our trig functions. So let's find the reference angle first for 150 degrees. So if I graph 150 degrees, my reference angle will be 30 degrees. So here's 150. If I have half a rotation, that will be 180. I'm going to take off the part that I don't want, the 150, and we see that the reference angle will be 30 degrees. Now, if I know what my reference angle is, I can actually use my special triangle. 30, that's going to be 1. Here's our 90, we'll have 2, and here's our 60 degree angle. That's of course the square root of 3. So if I know my reference angle, and I could find sine of 30 degrees, well, sine of 30 degrees would be opposite over hypotenuse, that would be 1/2. Then what is the sine value of 150 degrees? Well, let's first of all look through all of our sines. We are in quadrant 2. So what is positive in quadrant 2? Well, that of course would be sine and cosecant. All of my other trig functions will be negative. So I can already determine all of the signs of my trig functions. And now I will just look at the sine of 30 degrees would be 1/2. So it tells me the sine of 150 degrees would have the same numeric answer. So it would also be 1/2. What is the cosine of 150 degrees? Well, the cosine of 150 will be the same as the cosine of 30 degrees, since this is my reference angle. So that would be adjacent over hypotenuse. So that would be square root of 3 divided by 2. Tangent of 150 would be opposite over adjacent, so that would be 1 divided by the square root of 3, which we know would be square root of 3 divided by 3 when we rationalize. Now I can do with my reciprocals. The reciprocal of 1/2 is 2. The reciprocal of negative square root of 3 divided by 2 would be 2 divided by the square root of 3. And of course we want to rationalize. And the reciprocal of 1 divided by the square root of 3 would just be the square root of 3 over 1, or just the square root of 3. So we can use our reference angle to tell us the numeric values of all of our trig functions, and based upon the quadrant, that'll tell me the signs of all of my trig functions. Find the values of the 6 trig functions for 315 degrees. The first thing we want to do is graph 315 degrees. Two things that we want to know. We want to know what quadrant that we're in, and we can tell that we are in quadrant 4. And remember that the reason why I want to know the quadrant is I want to know the signs of all of my trig functions. So, what functions are positive in quadrant 4? Well, that would be cosine and secant. Everything else will be negative, so I can already put my signs in. And the next thing I would like to know is the reference angle. We know that the reference angle will tell us the numeric values that go behind the signs of all of my trig functions. So 315 degrees between its terminal side and the nearest x-axis, which we can think of as 360, that would be 360 degrees minus 315 degrees. That tells me that my reference angle is 45 degrees. So let's think of our special triangle for 45 degrees. So my special triangle would look something like this. Here's my 90-degree angle. Here's my 45, 45. The hypotenuse is square root of 2, and the sides are both 1. And we're working from the perspective of our reference angle 45 degrees. And we know that this would be the opposite side. This is my hypotenuse, and this would be the adjacent side. So sine would be opposite over hypotenuse. So that would be 1 divided by the square root of 2, which we know that when we rationalize, we get square root of 2 divided by 2. Cosine is adjacent over hypotenuse, 1 divided by square root of 2. So this time we get positive square root of 2 divided by 2 for cosine. For tangent, that would be opposite over adjacent, so that would be 1 divided by 1, which is just 1. Cosecant would be the reciprocal, so that would be just square root of 2, so the reciprocal of sine just be the square root of 2, and it's negative square root of 2. Secant, reciprocal of cosine, so once again that would be just square root of 2 divided by 1, which is just square root of 2, so we get positive square root of 2 for secant. And for cotangent, the reciprocal of minus 1 is also minus 1. So once we know sine, cosine, and tangent, we can use our reciprocal relationships to find the last three. It all goes back to what quadrant that we're in. That tells us our signs. What's our reference angle? That tells us all the numeric values of each of the trig functions. Find the values of the 6 trig functions for 420 degrees. First, let's graph our angle 420 degrees. We notice that 420 degrees is larger than 360, so let's find how many rotations need to be completed. So we have 360 minus 420, we get 60 degrees. So we have one complete rotation and then 60 degrees more. We can tell that since we went one complete rotation 60 degrees more, without any calculations to determine my reference angle, we can just tell that it's 60 degrees. So we know that our reference angle is 60 degrees, and we also know that we are in quadrant 1, which tells me that all of my trig functions should be positive. So we want to use our 30, 60, 90. And we need to know the sides of each. My hypotenuse is 2. Across from the 30 I have 1. Across from the 60 we have the square root of 3. Remember that we're working from the perspective of our 60-degree angle. So this would be the opposite side. This is my hypotenuse, and 1 would be my adjacent side. So sine of 420 degrees will be positive, and it will be opposite, so that will be square root of 3 divided by the hypotenuse, which is 2. Cosine will be adjacent over hypotenuse, which will be 1/2. Tangent is opposite over adjacent, so I get square root of 3. And then we can use our reciprocal relationships. when I flip sine, we get 2 divided by the square root of 3, which when we rationalize, we get 2 square root of 3 divided by 3. Secant is the reciprocal of cosine, so we get 2. Cotangent, the reciprocal of tangent, so that would be square root of 3 flipped, so that would be 1 divided by the square root of 3, and when I rationalize, square root of 3 divided by 3. So it's as easy as knowing what quadrant you're in to tell you the signs, and knowing the reference angle. We can work from the perspective of that reference angle in our special triangle to tell us the numeric values for each of those trig functions. Find the exact value of each expression. So for part A, we want to find sine of negative 150 degrees. So first I am going to graph negative 150 degrees. Of course, that would be going in the negative direction. And we want to do two things. We want to know the reference angle, and we also want to know what quadrant that we're in. We see that we are in quadrant 3, and we know that the sine value of our angle will be negative in quadrant 3. So let's go ahead and put our sine in. That's negative something. And in our reference angle, hopefully we can tell that we are just 30 degrees short of a half rotation. So the distance required to go from negative 150 to my nearest x-axis, of course, would be 30 degrees. So our reference angle would be 30 degrees. So we can draw our special triangle, and we can work from the perspective of 30 degrees. So here's 30 degrees. And we're working from the perspective of our 30-degree angle. This would be 1, 2, square root of 3. So the sine value would be opposite over hypotenuse, so that would be 1/2. So the sine value of negative 150 degrees would be negative 1/2. Now we want to find cotangent of 1035 degrees. So first we will graph our angle. Before I do that, I notice that I have more than one complete rotation. So let's find out how many complete rotations we have. We will divide by 360. In my calculator, I get 2.875. That means I have 2 complete rotations. So I will subtract 360 twice. And when I do that, I get 315 degrees. So we have 2 complete rotations, and then 315 degrees more. So go almost all the way around, but I'm going to stop just shy of a third complete rotation. And if the last part I did was 315 degrees, that was the kind of basically the coterminal angle there. What would be left over to go from 315 all the way to the x-axis to 360? So that would be, looks like 45 degrees. So our reference angle is 45 degrees. Alright, so we're working in quadrant 4. And is cotangent positive or negative in quadrant 4? It's negative. And we're working from the perspective of our 45-degree angle in our special triangle, 45, 45, 90. So remember that our hypotenuse is square root of 2, the other sides are 1. So if I'm working from the perspective of my reference angle, 45, cotangent, let's go ahead and label all of our sides here. We would have opposite, adjacent, and hypotenuse. And cotangent would be adjacent divided by opposite. That's 1 divided by 1, which of course just gives us 1. So the cotangent of 1035 degrees would be negative 1. Part C, we want to find the cosine of negative 300 degrees. So we need to know two things. I need to know what quadrant and what the reference angle is. So let's graph negative 300 degrees. I'm going in the negative direction. Negative 300 degrees. And we want to know the positive distance between the nearest x-axis and the terminal side. I think we should be able to tell that would be 60 degrees. 60 degrees then is my reference angle. And we're looking for cosine of negative 300. So cosine, we're going to get that value from our 60 degree reference angle, but cosine is positive in quadrant 1. So let's pull out our reference angle, 60 degrees, and let's find our triangle and what values would be in our 30, 60, 90 triangle. So across from our 30 is 1, our hypotenuse is 2, and across from 60 is the square root of 3. Working from the perspective of 60 degrees, we want cosine, and that is adjacent over hypotenuse, so that would be 1 divided by 2. So the cosine value of negative 300 degrees would be a positive 1/2. Lastly, we want to find secant of 750 degrees. So we want to graph our angle. So we can tell that 750 degrees is definitely more than one complete rotation, and in fact 750 is 2 complete rotations and a little bit more. So we'll subtract 360 twice, and when I do that, we should get 30 degrees. So we're going to go 1 complete rotation, 2 complete rotations, and then we have 30 degrees more. Once again, without actually doing another calculation, we can tell that the distance between the nearest x-axis and the terminal side would be 30 degrees. So here we have our reference angle, and we also know that we're living in quadrant 1, so secant is positive. And let's draw our special triangle, our 30, 60, 90. And remember that we're working from the perspective of 30 degrees. Across from that would be 1/2, that's the opposite side, or 1, that would be the opposite. Across from 90 degrees, we know that was 2. Across from 60 is the square root of 3. So we have opposite, we have our hypotenuse, and we also have our adjacent side. Secant is hypotenuse divided by adjacent. So that would be 2 divided by the square root of 3, and we need to rationalize. So we get 2 square root of 3 divided by 3. In this last example, we will do exactly the opposite of what we have been doing. I will give you the function value, and now I will ask you for the angle that creates that function value. And we are looking for angles from all 4 quadrants, so all the way from 0 to 360 degrees. So first of all, let's look for an angle that has a cotangent value of negative square root of 3. So we are looking in all 4 quadrants, and the angles we're looking for have a cotangent value of negative square root of 3. So it's negative. So first, where's cotangent negative? Cotangent is negative in quadrant 2 and in quadrant 4. So the negative tells me what quadrants that my angles will come from. The next thing I want to do is figure out what angles actually have a numeric value for cotangent of square root of 3. Now, if we think about our cotangent value as a fraction, let's put that over 1, and the definition for cotangent is adjacent divided by opposite. So if I was to pull up my special triangle, 30, 60, 90, and label all of my sides, negative square root of 3, let's just work with square root of 3, has to be the adjacent side, and 1 has to be the opposite side. What angle are we looking for that perspective where 1 is the opposite side? Well, that would have to be 30 degrees. So 30 degrees is the reference angle for the two angles that I am looking for in quadrant 2 and in quadrant 4. So let's first find what angle that we are talking about in quadrant 2. If my quadrant 2 angle has a reference angle of 30 degrees, then my angle must start here on the positive x-axis, and it must have a terminal side that stops just 30 degrees short of a half rotation. And hopefully we can see that that would be 150 degrees. So the angle in quadrant 2 that I am describing is 150 degrees. Of course, there is another angle in quadrant 4 So let's draw our reference angle in quadrant 4, and we want to know what angle we are describing here all the way around until we stop at the terminal side just short of a complete rotation, 30 degrees short. Well, 30 degrees short of a complete rotation would be 330 degrees. So we see that we have two angles that meet our requirements, 150 degrees and also 330 degrees. Now we would like to find the angles that have a cosine value of negative square root of 2 divided by 2. So first let's describe which quadrants we are looking for our angles. Cosine value is negative, so that would have to be in quadrants 2 and quadrants 3. Now we want to know what the reference angle would be for these two angles that have a cosine value of negative square root of 2 divided by 2. Let's unrationalize. The unrationalized version would of course be negative 1 square root of 2, and cosine is adjacent divided by hypotenuse. So when we pull up our special triangle here, that would be referencing our 45, 45, 90. We have square root of 2 as our hypotenuse, and the other sides are 1. So what angle are we describing? Well, it looks like we are working with the perspective of course, this is my hypotenuse, and the adjacent side would be 1. It looks like we're working from the perspective of a 45-degree angle. So that's my reference angle. So we have a 45-degree reference angle in quadrant 2. So what angle are we describing? So if I was to actually graph the angle that had this reference angle, I would start on the positive x-axis and then come just short, 45 degrees short of a half rotation. Well, that would be 135 degrees. So there's one of our solutions. And then we want to do the same thing, this time located an angle in quadrant 3. So let's erase this part here. And this time we're looking for an angle that has a reference angle of 45 degrees in quadrant 3. So there's my reference angle. And now if I was to graph the angle theta that has this reference angle, I would start here at the positive x-axis and go all the way around until I hit the terminal side. And of course that would be 180 degrees plus an additional 45 degrees. So that would be 225 degrees. So we have two angles that have a cosine value of negative square root of 2 divided by 2. Now we are looking for two angles that have a cosecant value of 2 square root of 3 divided by 3. We notice first of all that cosecant is positive, and cosecant is positive in quadrants 1 and in quadrants 2. So we are looking for two angles that live in quadrants 1 and quadrants 2. Now we would like to figure out what the reference angle is that we are going to use to determine these angles. Let's unrationalize that would be 2 divided by the square root of 3, and cosecant would be hypotenuse divided by opposite. So which angle are we describing? So let's go back to our special triangles. These 60, 30, 90, and let's draw in our sides. And 2 has to be the hypotenuse, and square root of 3 has to be the opposite side. So opposite would be referencing 60 degrees. So 60 degrees is our reference angle. So we are going to put a reference angle of 60 degrees in quadrant 1, and that would be 60 degrees. So our first angle theta would be 60 degrees. Now let's look for our reference angle in quadrant 2. So we have a 60 degree reference angle also now in quadrant 2. So from the x-axis up would be 60 degrees. And what angle actually would stop there for the terminal side? We're going to start on the positive x-axis and then come on around. And we see that we stop 60 degrees short of half rotation. So we see that would be 120 degrees. So we actually get two solutions, 60 degrees and 120 degrees. They both have a cosecant value of 2 square root of 3 divided by 3.